Now I request the IMC team to play University Tarana, whose lyrics are written by Honorable Vice Chancellor Professor Syed Ainul Hassan. Please, can we have the Tarana?
यहाँ से करे आसमान
का ये बागे शहरे इल्म है उर्दू ज़बान का ये बागे शहरे इल्म है उर्दू ज़बान का. Thank you. That was wonderful, Tarana. As a token of gratitude and appreciation, we would like to felicitate today's guest. अब मैं अदबन हमारे रजिस्ट्रार प्रोफेसर इश्तियाक अहमद साहब से गुजारिश करूंगा कि वो चीफ गेस्ट अजहर माजिद सिद्दीकी को शॉल और पॉट से नवाजें. Volunteers, can we have the shawl and thank you, Aparajita. Aparajita is a student of MSc Physics. Now I request Registrar Sir once again to felicitate guest of honor, Professor P.K. Suresh. शुक्रिया नरगिस. अब मैं डीन स्कूल ऑफ साइंसेज प्रोफेसर सलमान अहमद खान से रिक्वेस्ट करता हूं कि वो हमारे रजिस्ट्रार साहब को शॉल और पॉट पेश करें. Now I request Professor Alim Basha to felicitate our beloved Dean Salman Ahmad Khan. Thank you, everyone. Now I invite my colleague and convener of National Symposium, Dr. Priya Hassan, to deliver the formal welcome address. Dr. Priya Hassan.
Thank you, Rizwan. Thank you. So it first of all gives me great pleasure in wishing everybody for National Science Day 2024. That's today. And because we have all the School of Sciences, so on behalf of the School of Sciences, I'd wish everybody, which is a very important day for our country. We need to understand the importance of science and celebration of this day. So as part of the celebration of this day, we have very esteemed guests with us today. So first of all, I'd like to thank the registrar, Professor Ishtiaq Ahmed sir, for having spared some time for us to come for our event today. And our guest of honor, Professor Sir Siddiqui sir from Jamia Millia. He's going to give us the keynote today for National Science Day. And our guest of honor, Professor P.K. Suresh from University of Hyderabad, who's going to start a physics symposium immediately after the Science Day lecture. We are going to have a national symposium on recent advances in current physics. And the keynote address will be given by Professor P.K. Suresh, who's with us today. I'd like to thank our section head, physics section head, Professor Alim Basha, and our dean, Professor Salman Khan sir, for having supported us in having this event. So welcome everybody, and I'm very happy to start off our event. Yeah, thank
you. Thank you, Priya. As most of you know, School of Science is an integral part of any university. School of Science at Manu is also actively involved in both research and training. Uh, to tell you more about School of Sciences, I would like to invite the person who is leading the School of Sciences, Dean Professor Salman Ahmad Khan. Sir, please.
Assalamu alaikum and very good morning. Welcome you all. Registrar Manu, Professor Ishtiaq Ahmed Sahab, Chief Guest of today's program, Professor Azhar M. Siddiqui Sahab, Department of Physics, Jamia Millia Islamia, New Delhi. Today's our keynote speakers, Professor P.K. Suresh, Department of Physics, Central University of Hyderabad. Distinguished guests, our colleagues and dear students. I feel extremely glad to welcome everyone to National Science Day 2024. I welcome Professor Ishtiaq Sahab, Professor Azhar Sir and Professor P.K. Suresh Sahab for accepting our invitation to grace the occasion. As all of you might know, the National Science Day is celebrated every year 28th February to mark the discovery of Raman effect by Indian scientist Sir C.V. Raman on 28 February 1928. For this discovery, Sir C.V. Raman was awarded Nobel Prize in Physics 1930. The National Science Day is celebrated as one of the main science festivals in India every year. To celebrate this event, School of Science has organized a lecture on topic effect of swift heavy ion irradiation on conjugated polymer by eminent scientist Professor Azhar M. Siddiqui Sahab, Department of Physics, Jamia Millia Islamia, New Delhi. I welcome you, sir. I welcome all the delegates and wish to inform you that our university, Maulana Azad National Urdu University, is the central university having A+ grade in NAAC ranking. The university is named after Maulana Abdul Kalam Azad, a renowned freedom fighter and first education minister of independent India. The School of Science was established 2006. Currently, we offering the UG, PG and PhD program in zoology, botany, physics, chemistry and mathematics. Along with these regular programs, School of Science also offering the self-financing vocational program at UG and PG, VWOC and InWOC, medical imaging technology and medical lab technology. To taking the advantage of this occasion, I am happy to inform you that last week, School of Science successfully organized one international conference on recent and advanced in applied chemical sciences organized by chemistry section and one national workshop on molecular biology and bioinformatics organized by zoology section, one national workshop on MATLAB and its application in scientific computing jointly organized by the mathematics department and physics section. I am happy to inform you that today physics section School of Science is also organized a symposium on current advance in applied physics. This symposium features on the exploration of the discussion to the latest development and breakthrough in the field of applied physics. Two more conferences and workshops are scheduled in coming days. One International Urdu Science Conference on Science for Sustainable Future from 4th to 5th March will be organized by the School of Science. National workshop on genomic data analysis from 6th to 7th March will be organized by the Botany section. I congratulate Head Department of Physics, Professor Alim Basa Sahab, and convener of this program, Dr. Rizwan Sahab, and other colleagues and research scholar of the physics section for organizing this program. I wish a great success of this program. Thank you one and all. Thank you, sir.
Thank you, sir. So, as Priya ma'am mentioned earlier, along with this National Science Day celebration, we are organizing a two-day national symposium on current advances in applied physics. So, I'm also given the job of briefly introducing the workshop. This symposium is mainly possible due to support and encouragement of our Honorable Vice Chancellor and Registrar, sir. I'm not just saying just as a mere formality, because they are always encouraging, as just now Dean sir said, like we have been organizing so many programs, different departments. It is just because of their support and like so financial, all kinds of support. So it is all possible because of their support. This is a first of its kind program being organized by physics section. In past, physics section has organized extension lectures and workshops on specific areas like astronomy, astrophysics, and workshops on Python. But this time we thought we would like to bring all the different areas, research areas of physics in one on single platform. So we have kept the focus areas, choosing like almost to cover all the areas. So we have astronomy, astrophysics, cosmology, atmospheric sciences, biophysics, nano and material sciences. Like nowadays, that is one of the most applied area of physics, nano and material science, laser and optics. So in this 2 days program, we have arranged a keynote lecture, invited lectures, where we have tried to cover all the areas which we have mentioned in our title. So to do a justice to our title and our focus areas. We also have like paper presentation from 26 participants, and 5 poster presentations are also there, which is very encouraging for us because and we have participants from like in both offline and online mode. So it is quite encouraging for us, because when we started this like 1.5 months, we were I mean, particularly I was skeptical that whether we will be able to get, but the kind of response has been very good. And all this is possible because Alim sir had confidence that we can do it, and some of our young colleagues took the initiatives. So we are here today, and I hope that these 2 days will be very fruitful to all the participants and for us, and we will have a very like learning experience after these 2 days of this symposium. And we have actually the all the invited speakers were on a short notice, they accepted our invitation. So we have very good speakers. So I request all the students of MSc and our undergraduate students to do participate in all the lectures. You will learn a lot. Uh, Thank you. So now this session is particularly dedicated to National Science Day. So tell you more about today's significance and introduce today's lecture, I would like to invite Professor Alim Basha, Head of Physics Section, to come and give introduction to Science Day, and Science Day speaker Professor Azhar Majid Siddiqui. Thank you.
Assalamu alaikum. Good morning to all of you, and warm welcome to all of you again. Respected President of today's session, Professor Sheikh Istaq Ahmed, sir, our Honorable Registrar for Manu, respected Speaker of today's event, Professor Azhar Majid Siddiqui from Jamia Millia Islamia, New Delhi, respected guest of honor from University of Hyderabad, Professor P.K. Suresh Garu, Professor Salman Ahmad Khan, Dean, School of Sciences at Manu, my colleague Dr. Rizwanullah Kansari, convener of today's event, my dear colleagues, research scholars, students, and participants in hybrid mode, that is both offline and online. Assalamu alaikum. नेशनल साइंस डे यानी कौमी साइंस का दिन साइंसी तहकीकात और दरियाफ्त का जश्न है, जो सर सीवी रमन के जरिए रमन असर की दरियाफ्त की सालगिरह के मौके पे मनाया जाता है। नेशनल साइंस डे हर साल 28 फरवरी को हिंदुस्तान में मनाया जाता है, ताकि 1928 में सर सीवी रामन की तरफ से रमन इफेक्ट की दरियाफ्त की याद मनाई जा सके। इस साइंसी दरियाफ्त ने उन्हें 1930 में तबीयत का यानी फिजिक्स का नोबेल प्राइज हासिल करवाया। नेशनल साइंस डे का थीम इस साल के लिए 2024 के लिए एक पायदार मुस्तकबिल साइंस है। एक पायदार मुस्तकबिल के लिए साइंस है। ये थीम आलमी यानी वर्ल्ड वाइड चैलेंजेसों से निपटने और सबके लिए ज्यादा पायदार मुस्तकबिल बनाने में साइंस और टेक्नोलॉजी के अहम किरदार की निशानदेही करता है। The journey began in 1928 when physicist Sir C.V. Raman, Indian physicist Sir C.V. Raman, made the remarkable discovery of Raman effect, which is a scattering of light in inelastic collisions with molecules. This groundbreaking discovery earned him the Nobel Prize in Physics in 1930, marking a significant milestone for Indian science. The National Council for Science and Technology Communication proposed to establish a dedicated day to celebrate science. Following the government's approval, February 28 was formally declared as National Science Day in 1986, marking the first official celebration in 1987. So now we are celebrating 37th Science Day nationally. The Raman effect is a powerful tool with diverse applications in various fields, which provides a non-destructive and sensitive technique for studying various materials and processes, leading to advancement in scientific research, technology development, and quality control in various industries. Significance of today's day, that is National Science Day, to celebrate a groundbreaking scientific discovery, to recognize the contributions of scientists, to highlight the importance of scientific temper, to encourage young people to pursue careers in science and technology. This National Science Day plays a very important role in building a strong scientific foundation for India's future, promoting innovation and technological progress, enhancing the quality of life for all citizens, creating a more sustainable and equitable future for the planet. So National Science Day will continue to inspire and empower individuals and communities to build a brighter future for all of us. So we can celebrate, we can take this day as a special day for science people and science lovers. Now, I request, this is the background and history of your National Science Day. Before proceeding towards the keynote speaker or the keynote lecture for today's celebration by Professor Majid Ali Siddiqui, I would like to request our registrar to please release our book of abstracts for current advances in applied physics symposium. Now I request all of all the DAS members to please release the abstract book. जी जी Thank you very much to all of you. So now I would like to give some brief introduction to our for the keynote speaker, Professor Azhar Majid Siddiqui from Department of Physics, Jamia Millia Islamia. He is presently working as a professor in Department of Physics, Jamia Millia Islamia, New Delhi. He studied his BSc honors from Osmania University. Basically, he is Osmanian and Hyderabadi. He has completed his MSc Physics from Aligarh Muslim University in 1991. After that, he has completed MPhil in 1993 from School of Physics, University of Hyderabad, and PhD from School of Physics, again University of Hyderabad in 2000. Under the supervision of Professor Anand Pathak sir, and he has this Majid sir produced, means guided 5 students for PhD degree under his supervision, and 6 students are still working for PhD program. He has already supervised 10 MSc projects. He has vast experience of teaching and research of 30 years, and he is a key person in designing MTech and pre-PhD syllabus at Jamia Millia Islamia for nanotechnology in MTech. And he has published 50 research papers, both national and international level. He has completed numerous projects from UGC and other funding agencies. He has visited abroad thrice, and he has attended given many invited lectures nationally. And at present, he is working in the field of nanotechnology because of their electrical, chemical, physical, electrical, chemical, thermal, and dielectric properties. In order to improve the interaction of your nanotubes for the transfer of those properties into the bulk. Now I request, before going to start this, means before delivering his lecture, I request our registrar, Professor Sheikh Ishaq Ahmed sir, to say a few words. Thank you once again.
Thank you very much. Assalamu alaikum. First of all, we all have gathered. It's a very happy moment that the School of Sciences, especially the physics section, and others also have taken a lead in holding this Science Day. This Science Day is really very important. It's, as Professor Alim Basha said, that it's a great source of encouragement for all of us, and for especially all the research scholars, students, teachers, faculty members, scientists who are working in various fields of sciences. So it's a very happy occasion that we are organizing a 2-day national symposium on a very important topic, that is current advances in applied sciences. And for this, we have invited our school, or our physics section has invited 2 very learned speakers, and they are known for their dynamic research. They are known for their contribution in the field of sciences. So give a big hand to our 2 honorable learned speakers. The chief guest, Professor Azhar M. Siddiqui Sahib from Jamia Millia Islamia, New Delhi, and our guest of honor as well as the speaker, Professor P.K. Suresh Sahib from University of Hyderabad, and both of them are going to deliver very specialized uh, lecture, and their lecture is the outcome of their researches that they had been doing in their field. It's important to note that in this symposium, this is in hybrid mode, and as I have been told that a good number of participants from all over country, from various universities, various institutes are participating in large number. And as soon as the registration was opened, a large number of participants have registered, and it had not been able to accommodate all of them, but a good number of them are going to present their papers. They are going to share their researches, and our students who, as our School of Science, it is running our graduation program, PG program, as well as PhD is already there. So the students have also joined in good number, and I do hope that out of those presentation in these 2 days serious deliberation, it will be very meaningful discussion, and our student, our research scholars will learn a lot, and they will be guided by our senior colleagues, our faculty members, our speakers, our participants. So it will be a good occasion for all of you to learn the and know the latest researches or latest challenges that the science is facing or the science is going to contribute. So I can wish you all the very best for this 2 day national symposium, with the hope that all of you will enjoy. Actually, as of you know that tomorrow we have another program, and our chief guest is none other than Professor M. Jagadish Kumar. He is also a scientist. He is from Indian Institute of Technology, Delhi, and presently he is chairman of the University Grants Commission. So tomorrow by this time we will be with him, inshallah, in this auditorium. So all of you are invited for tomorrow's program also, and due to his arrival to our university and due to his participation in tomorrow's program at our university, we are slightly busy in shaping the programs and still finalizing many more things. Just now I got a call from his office also. There are some deliberations are going on about the program and all that. So why I am sharing, first I am sharing to invite all of you on behalf of the Honorable Vice Chancellor and the university, and second that I am slightly busy in due to his visit, due to that program. So I will not be able to stay here for a longer period. But I do hope and I know that these two speakers, Professor Azhar M. Siddiqui Sahab and Professor P.K. Suresh Sahab, will really deliver a very wonderful lecture before you. I wish you all the best. And I'm also thankful to all our senior faculty members who are off the dais. They had been working a lot, guiding a lot. And in the past 2 3 years, we have seen that the School of Science has really made some remarkable contribution as far as our publication is concerned, as far as various programs that is run by the School of Science is concerned. So my salute to all my teachers and students. Thank you very much.
Now I invite chief guest and today's special lecture guest, Professor Azhar Majid Siddiqui, to come and deliver his lecture.
नहीं नहीं हम कम से
Assalamu alaikum and good morning, everyone. At the very outset, let me thank all of you for inviting me, giving me an opportunity. And I'm also very happy to see lot many old faces and new faces, of course. My dear friend, P.K. Suresh. ये उस वक्त हैदराबाद यूनिवर्सिटी से हमसे मुंसलिक थे जब मैं पीएचडी मतलब हैदराबाद यूनिवर्सिटी छोड़ रहा था और ये ज्वाइन कर रहे थे. It was a nice occasion for me meeting. And then, of course, हमारे नामकार माजिद साहब. Before I start my talk, एक चीज जरा मैं इन द बेनिफिट ऑफ एवरीवन ये बताना चाहता हूँ. कुछ हेल्थ इशू मेरे साथ रहा था जिसकी वजह से जो है देयर आर सम मतलब मेरी टॉक नॉर्मली ऐसी होती थी कि द टॉक गोज ऑन एंड ऑन. आप लोग जब तक ना कहें तब तक मैं बोल सकता था. आई वाज इन ए पोजीशन. तो अबाउट एंड जो उर्दू साइंस कॉन्फ्रेंस शुरू हुई उसके जो है को फाउंडिंग मेंबर्स में मैं वन ऑफ द मेंबर्स आई वाज आल्सो देयर. तो उसके बाद हेल्थ का कुछ ऐसा इशू आया कि आई हैड टू टेक अ ब्रेक ऑफ अबाउट 4 years मे बी. और उसमें उस बीच में मैंने एक चीज़ रियलाइज़ की बिफोर आई कम टू माई टॉक विच इज देयर प्रेजेंटेड देयर. तो इसमें आने से पहले मैं अपने हेल्थ इश्यू के बारे में बताना चाहता हूँ बिकॉज आई एम टेलिंग दिस इन द बेनिफिट ऑफ एवरीवन. तो ये पैरालाइज हुआ था मुझे और उस पैरालिसिस की वजह से व्हाट एक्चुअली हैपेंड वाज आई लॉस्ट द सेंस ऑफ रीडिंग एंड राइटिंग completely. And that became a really a shock to me. मेरे अपने नाम के अलावा मैं कोई चीज़ पढ़ने के काबिल ही नहीं था. That puts you in problem. उसका जो है रेमेडी जो है वो बाद में पता चली कि इसका जब अटैक होता है तो उस अटैक में विद इन 4 years यू आर गिविंग एन इंजेक्शन और उसमें जो है रिवाइज एवरीथिंग. और वो अगर 4 hours अगर आप लूज कर गए तो देन इट कैन टेक यू टू एनी लेवल. मेरा तो बहुत छोटे लेवल पर आया. उस छोटे लेवल में मैं पढ़ना लिखना भूल गया. अदर देन लूजिंग माई आई साइट ऑन द राइट साइड. अब बियॉन्ड दिस पॉइंट आई कैन नॉट सी एनीथिंग. तो इतना दिखता है, इससे आगे आई कैन नॉट सी एनीथिंग. तो वो तो है अपनी जगह, लेकिन जो सबसे ज़्यादा शौक जो मेरा ब्रेड एंड बटर है वो जो है पढ़ना लिखना था. और उससे बड़ा शौक ही आया कि आई वॉज नॉट एबल टू रीड anything which is other than my name. Then what I'm going to do for the rest of my life? And I got suggestions from people, me and my near and dear ones in the office and every place. And now I think you can take retirement. Then I said nothing doing, keep quiet. I have to relearn and I have to rebuild up myself. So I started learning. अगर आपको हैरत होगी जान के कि मैंने जो है फिर कुरान पाक को अलीफ बा ता से पढ़ना शुरू किया आदमी को बिठा के. एंड दैट लॉकडाउन प्रूव टू बी हेल्प मी अ लॉट. एट लॉकडाउन वी वर टोल्ड नॉट टू कम आउट ऑफ द हाउस. ओनली 5 people आर अलाउड इनसाइड द मॉस्क एंड नोबडी इज कमिंग आउट, सो ऑन एंड सो फोर्थ. मैंने एक आदमी को पकड़ा, उनसे वो मेरे उस्ताद हैं, उनसे कहा कि वो उनके लिए मस्जिद जाना अलाउड था. तो मैंने जो है वो जो 5 आदमियों की परमिशन थी, उस 5वें के बाद मैंने कहा मैं 6ठा आदमी हूँ, मैं रहूँगा, नोबडी इज गोइंग टू स्टॉप मी. तो देन आई स्टार्टेड लर्निंग फ्रॉम अलिफ बाता लिटरली एंड दैट हेल्प मी इन लर्निंग रीलर्निंग माई सब्जेक्ट ऑल्सो. And that's where so what I'm going to show here in my presentation is only a part of my the research. And it so happened that a few of my scholars जिन्होंने अपना काम ऑलमोस्ट कंप्लीट कर लिया था और लॉकडाउन लगा था, तो दे वर ऑल्सो नॉट इन ए पोजिशन टू डू व्हाट दे वांटेड टू डू. लेकिन एक चीज़ अच्छी ये हुई थी कि मेरे हर स्कॉलर के साथ एक को सुपरवाइजर थे. एंड एट द टाइम ऑफ माई इलनेस वो को स्कॉलर्स ने को सुपरवाइजर्स ने काफ़ी उनके साथ काम करवाया और ऐसा हुआ कि फिर अभी आपने जो देखा है, बाकी सारे बच्चों ने अब अल्हम्दुलिल्लाह सारे 9 बच्चों ने अपना पीएचडी कंप्लीट किया इसी तरह से, अल्हम्दुलिल्लाह। तो काम बच्चों का मुतासिर नहीं हुआ, बिकॉज ऑफ माई सिकनेस नोबडी गॉट अफेक्टेड बिकॉज ऑफ दैट, मतलब उनका पीएचडी में इफेक्ट नहीं पड़ा। फाइनली मेरा अपना जो ब्रेड एंड बटर था वो रिसर्च में द यूज ऑफ एक्सेलरेटर्स इन रिसर्च। एक्सेलरेटर जो यूज करते हैं उनका जो है सॉलिड स्टेट फिजिक्स में क्या यूज, मटेरियल साइंस में क्या यूज होता है, उस पर मेरा काम है सारे का सारा। तो माई टॉक इज बेसिकली ओरिएंटेड टुवर्ड्स दैट ओनली। इफ यू गो थ्रू द इनिशियल दिस थिंग, सो व्हाट आई डिड इज थोड़ा सा मैंने अपनी इस टॉक को थोड़ा सा मॉडिफाई यूं किया है कि मैंने इंट्रोडक्टरी पार्ट जो है कॉलर हाँ, नहीं, I'm comfortable this way, but only thing is I will be turning towards that. Okay. So what I do is the use of accelerators in material science. So what I have planned to talk about is the introduction to conjugated polymers, the first place. So how they are used. When we say polymers, what comes to our mind is insulator. I mean, plastic जो भी होगा वो insulator की तरह use होता है, but nowadays we use these polymers as. Am I audible now? Okay. So the use of the polymers when we talk about polymers are insulators basically. We understand that. Lekin now it has been discovered that polymers are conducting also. They are called conjugated polymers, and what way they are used. Many applications. The applications are basically when a polymer becomes a conducting in nature, it can go up to the tune of semiconducting nature, it can go up to the tune of conducting nature also. So when they are semiconductors, we can use them as, yeah, thank you. We can use them in that all electronics, and that's where यहाँ पे आके आप एक ब्रेक थ्रू मिलता है. दैट ब्रेक थ्रू इज द फोल्डेबल काइंड ऑफ एक्सेलरेटर, फोल्डेबल काइंड ऑफ ट्रांसिस्टर्स, फोल्डेबल काइंड ऑफ टीवी स्क्रीन्स, है ना, and that's a big breakthrough. And the computer screens, the flexible computer screens, so on and so forth. There are many such applications. So that is one good thing about these conducting polymers. Now they call it conjugated polymers. Okay, and what all they can do is the structural, the optical, the morphological, and all these changes, chemical changes, and what effects they are producing basically before the acceleration and after the acceleration. After and a small sentence that we write, a small word that we write there is a swift heavy ion. If you can go through that, swift heavy ion use. So SHI radiation, and jokingly we use today. See, I use accelerator physics, my basic bread and butter. Okay, so when I do acceleration, the first accelerator that has been used is to accelerate helium ions, the alpha particles. So helium ions, they call it He, है ना? Chemical name is उसका He, helium, and the use of helium ions. But then with that helium ion, we can go beyond. It has a restriction on its energy, that is 4 MeV only. In fact, lesser than 4 MeV. Swift heavy ion जो हम यूज करते हैं SHI, वो है any ions which are metallic in nature, and the energies they go on up to from 40 MeV onwards up to 150 MeV, 200 MeV. That is our limitation, and now we are at IUAC, Inter-University Accelerator Center in Delhi. Now we are augmenting it to have an energy of 800 MeV. So it is in the developing stage of that. I think they will reach it within a year or so from now.
and we'll start it. So what we used to say in jokingly is helium ion जो use होता है उसकी MeV is restricted up to 4 MeV and shift heavy ion की energy जो है it starts from 40 MeV onwards. So helium ion को He लिखते हैं and shift heavy ions को SHI लिखते हैं. So what he can do, what he was not able to do, she can do it, we say. Okay, so that's jokingly we used to say. So what will happen to the effect of what are the effects of shift heavy ions on conjugated polymers? That is my basic thing. इसी को मैंने अपना टाइटल बनाया है. So what and all can happen? Um, what and all can happen to the material और इस चीज को स्टडी करने के लिए we have been using it at lower energy levels, but then lower energy levels have some their own restrictions. So then we started with heavy ion energy, and I probed alpha particles, the helium ions, not the helium ions, the silver and gold particles at MEVs, which I will come to in the during the duration of my talk, and uh, at 100 MeV, 150 MeV. Here I will be presenting 100 MeV ions, helium ions, and what are the effects that I produce afterwards. Okay, so maybe next slide. We also see the DC conductivity and AC conductivity, changes in the DC conductivity
kind of this what's happening to when an alpha particle is it impacts any material, and what happens when the alpha particle comes back. Okay. So it didn't stop there. That was an experiment to give only the structure of the atom, as we all know, है ना. रदरफोर्ड बैकस्कैटरिंग का एक्सपेरिमेंट जो था वो एक बहुत इनिशियल एक्सपेरिमेंट वे बैक इन द अर्ली 90s, 1905 I believe, somewhere around that, or previous. Based on that, he gave the structure of the atom and so on and so forth. Now material scientists are they think beyond a point, ना. जो रदरफोर्ड ने जो काम किया था, मैं अपने स्टूडेंट्स के लिए बताता हूँ कि रदरफोर्ड had given just a hint and what's happening to the atom and how is an atom, so on and so forth. But then material scientists ने उसी experiment को use करके what is basically happening, if this is happening to the material, then the atom, the material that is present there should be something, है ना. Then they started material itself. That's what the place of the material scientist has started, right? So we use those experiments, the breakthrough experiments, to study how the material looks like. So it started with a simple alpha particle bombardment on a material and study how many number of particles are coming back. The number of particles that are coming back are called fluence. I'll use that term as a fluence also here. Fluence means number of particles going, hitting, so on, right? And coming back, the number of particles that are recorded back. Okay. So this term of fluence I will be using in my other studies or other slides also. So I was restricted to up to alpha particle 2 MeV to 4 MeV. Now, as I said initially, don't restrict your energies to 4 MeV. That means you have to change the particle which is bombarding. So we change the particle from proton to now any atom in the periodic table, right, from the iron, cobalt, nickel, gold, any such material, and then bombard those materials and see the after effects. So, and this is divided into two parts, as I said. Low energy ion beams. Low energy ion beams again is used to study the material for different purposes. But then when this low energy ion beams impinges on the solids, it does not have the capacity to record beyond a number of monolayers, and each monolayer is about 1 to 2 angstroms. So it goes up to some 10 monolayers or 20 monolayers at the most. 20 monolayers के बाद वो एटम वापस नहीं आ पाएगा, impinging जो हाइड्रोजन एटम और हीलियम एटम है. Okay, so it is restricted up to say 20 MeV, 20 monolayers, not more than that. When you increase the energy to 40 MeV onwards, so now it can go down up to 200 nanometers. So within 200 nanometers, the material that is present there, and that makes a change. You know? That material goes inside. When it goes inside, it creates some trouble, and that trouble I am not able to show you here. The trouble that happens here, which pointer, yeah. That trouble that happens here also. Yeah. Yeah. The trouble that happens here, now this particle is going and impinging, so it goes inside, creates some problem here, but then at this level, इसने क्या किया? Number of atoms that are there inside had tried to come out a little bit. I mean, we called it and be mixing. The number of particles go inside, some number of particles come outside. So 10 to 20 nanometers के अंदर, within those 10 to 20 nanometers, a few number of atoms go inside, a few number of from inside come outside, and the changes that take place, that is called the ion beam mixing, and that ion beam mixing leads to a very good material which jiska jo hai resistivity and conductivity they have not thought of before, no, they have not been imagined before, and that has happened here already, which an energetic particle has given rise to. That is something which we normally specialize in doing that. My students, I mean, not just me, many other people. Okay, next slide. But then when that happens, इससे पहले एक बार शायद, it's just back. Yeah. But then to study that, we have to study how this is happening and what changes are basically happening inside at the atomic level. When we do that at the atomic level, then there are two models that are given. One is the Coulomb explosion model, and the other one is the other one is the next slide. Just a minute. Next slide. Yeah, next. Yeah, the thermal explosion model, है ना? So I'll go back to the previous slide, please. Yeah. Yeah, here what happens actually happens is the Coulomb explosion means you can I think it's very clearly explained here also in the figure itself. Energetic ion is going through, and when it is going through, you imagine your particle has to be positive alpha particle or heavy ion. Both all the particles are positively charged. Okay. Negatively charged particle key, we have not studied them so far, because what we normally believe and understand is that the electrons that are present, इसकी negativity जो है वो इतनी affect नहीं करती. Electrons are simply playing a role of giving you a screening. You have two north pole and north pole of a magnet. You put a magnet here, and in between you insert a paper. Then what happens? The reflectivity is slightly affected, but then it remains a reflective in nature only, है ना, repulsive in nature only. जो दो north poles हैं, वो north poles जो है वो attractive नहीं बन जाते, they are still repulsive only in nature. Only thing is उनकी strength कम हुई, which is what an electron is also doing. Electron की cloud है, एक electron नहीं है, cloud of electrons है, but all those electrons, all said and done, are only providing a screening. So what I understand, and what I means everyone, what we understand is that the particles, that positive particles that are impinging on the material is interacting with the nucleus of the target, and electrons are only giving me a screening function. So what I do is normally find out the Coulomb interaction in between them. Coulomb interaction, remember, Coulomb interaction in between them, with electrons only giving me reducing the number of repulsion, but the repulsion is still repulsion. It is just a screen that is being provided by the electrons. So I'll talk about only the repulsion between these positive particles, and that repulsion gives rise to the effects which are actually happening in with the changes in the material. So we call it the Coulomb explosion. This model is called Coulomb explosion, which is effective normally for non-conducting, for conducting materials. जो conducting materials होंगे उनके ऊपर ये effect ज़्यादा महसूस होगा. जो non-conducting materials के लिए I use a different model, and that is called the thermionic emission. Next slide. Next slide, yeah. दो स्लाइड आगे चले आइए. इससे पहले और पहले ये thermal explosion model, right? Thermal spike. So thermal spike model that works on for those materials which are non-conducting in nature, non-conducting material है, semi-conducting भी नहीं है, non-conducting है. And when I have a non-conducting material and a heavy ion is impinged on that, so conductivity will not have, I mean, the electron charge, the positive electron as a positive proton, so on and so forth. These kind of things are not doing anything there. Lekin the impact of heavy ion on a non-conducting material, what can happen? कूलम एक्सप्लोजन तो नहीं हो सकता, लेकिन एनर्जी बढ़ जाए, टेम्परेचर बढ़ जाएगी. So that's why it is the thermal explosion, thermal spike model. At that particular place, the temperature rises suddenly up to a few hundreds of degrees in a very short span of time. और मटेरियल पर अगर टेम्परेचर अचानक से बढ़ जाए, थर्मल स्पाइक हो जाए, and that thermal spike can give rise to, and that thermal spike happens to be of a very short durations that are of some microseconds, and within that short span of time that temperature has changed and gone back, and it has gone back, the new material has taken place. Okay, that is the thermal spike model. So that's what we have been trying to do it for the past many years. We have tried to do it for materials which are semiconducting in nature, but those are normal semiconductors, and then we passed on to polymers, conducting polymers, and conducting polymers पे shift heavy ion use करके. That's what is my talk is basically on. Next slide. Yeah. So what happens here could be many things, लेकिन जो अच्छा चीज, the thing which we have to depend upon is the kind of ion that you are using. कौन सा ion use किया, and that ion will give you what result. One thing, the type of ion, the energy at which it comes. Okay? High energy 40 MeV है, 50 MeV है, 100 MeV है, or beyond. Like I said, I go maximum up to 180 MeV, 200 MeV. Maximum may be used up to 200 MeV. After effects बाद में हमने मतलब still higher energies like जो IOAC में होता है, इंटर यूनिवर्सिटी एक्सेलरेटर सेंटर. मैं थोड़ा सा एक छोटा सा ब्रेक आपसे ये ले रहा हूँ कि there is an accelerator that is in New Delhi. It is called the Inter University Accelerator Center. It has an accelerator where you can go and from energies to from 40 MeV up to 200 MeV one phase. Now they have augmented that from 200 MeV. Now they have gone up to 800 MeV and beyond. कोशिश कर रहे हैं उससे ज़्यादा आगे जाने की, GeV तक की एनर्जी ले जाने की, and almost it has come to final stages. Maybe in a year or so we can get news from that also. लेकिन उसके जो effects होंगे, those energies people have studied. I mean, one such facility which is there in India itself, and that facility is for everyone who wants to work on this, and they have 5 dedicated beam lines. Energetic ion, that energetic ion is, the accelerator happens to be on 7th floor of the building. There you excite an electron, excite a positive ion, accelerate it down the lane. Okay, down the lane means 7 floors down. Okay, then you transfer it, make it a horizontal beam, and that horizontal beam is shot at the material. When it is shot at the material, you have the ability to shift it on the one beam line, the second beam line, the straight beam line, then on the left hand side one beam line, finally on the left hand side second beam line, and each and every place it is dedicated for different studies. One is meant only for nuclear studies, one is meant to only see what are the different energies giving rise to new material, or at this energy what material that comes out, different types of material atoms that come out of it, and at that energy what are they going to do with the magnet, so on and so forth. There's a different studies separately, and these two, the straight beam line is used to accelerate further higher. Okay, so it is dedicated for 400 and 800 MeV, and the other two beam lines are used for material science. Yeah, in the material science, they can use it for 100 to 50 to 100, 200 MeV. So these two beam lines are dedicated for this irradiation. So and energy and fluence, as I said, the affluence means how many number of atoms are being shot, and in how much time. Given this time, how many number of atoms are being shot at it? How many number of proton, the alpha particles are going there? Okay, and then what species, right? Same energy, helium ion. Same energy, the gold ion, and same energy, the iron beam. Okay? What happens to it? So different ions, different beams. Okay. Now after that, what we do normally is when that happens, the chemical effects, uh, optical changes, the chemical changes, the thermionic changes, and the temperature has increased suddenly. It has spiked from 40 degrees centigrade to 400 degrees centigrade, and what change that has happened there. So thermionic effect, so on, and electrical conductivity. If these changes happen, then obviously the conductivity changes. Conductivity changes means magnetic properties also changes. When that happens, it can result into a new material itself, totally a new material. So that's what is basically studied, and um, that's what we have been doing. And now I come to few of the results that I'm going to show. Okay, next slide. Yeah, so what we have to see basically is, as I said, at lower fluence, what is happening? I mean, lower fluence means these many number of particles have been bombarding the material with a particular ion for, let us say, for 10 seconds. What happens? Now at that 10 seconds, or about, let us say, it gives me in these many number of particles in about an hour. If these many number of particles have gone in about an hour, then I call it a different fluence. At that fluence, what change has happened? And then I change that time again, say different, same sample, different beamline, different time, okay, different time, and same energy same, but the time has increased. Time of bombardment has increased. That is what is the fluence basically. And then different fluences, what happens to the energy? What we find out is, sometimes, in my cases, what happened is a particular polymer gave rise to a very good conductivity at a particular fluence. Conductivity increases suddenly. But then I keep on increasing the fluence, the conductivity reduced. Same thing, same material, same ion, okay, for a particular number of time, it gives me good conductivity. I increase the fluence, the conductivity reduces further. So which one is of most use to me? I will study that, take that particular fluence material, and then use it for the applied for my application. And that's what has been written here completely. All these things have been done already. So what we started basically from bombarding the materials with different fluences and different beams also. What I did is basically started with gold beam, and then switched over from gold to silver to aluminum, and then of course we choose the carbon beam also. Same thing, carbon beam. Then what we did is different energy, different same energy, different beams, so on and so forth. Likewise, we kept on changing the materials, ions that are bombarded on that, and studied that. So finally, I'll show some of the results of one such a study. मैं सारे results तो फिल वक्त दिखा नहीं सकता. So next slide. Yeah. So next slide. So this polymer, uh, what we found out was that one of my students, he is trying to build up a polymer which was giving me um, a good result for initially what I had shown. Now, one second. I just wanted to show that, highlight that, because that's very important from the point of view of application, because this is the new material. अब आप लोग जो देख रहे हैं फोल्डेबल काइंड ऑफ सेमीकंडक्टर, फोल्डेबल काइंड ऑफ डिवाइसेस, है ना, सेलफोन नॉर्मली इनिशियली तो बड़ा बड़ा आया था, फिर छोटे हुए, देन वी स्टार्टेड स्मॉलर वंस, देन वी स्टार्टेड टू आईफोन्स, सो ऑन एंड सो फोर्थ. अब जो सेमीकंडक्टर्स ने the foldable kind of devices have already come into the market. So I have a device that can be folded, one fold, second fold, third fold, and put it in my pocket, and it looks like a paper which I can fold multiple times. Here, like this, I can fold it multiple times. That kind of semiconductor, that kind of devices have already come into the market, and I don't know, very soon it will become public usage things. Okay, that is something, and that has happened only after we found out the supercapacitor and sensors. Its main application is in sensors. Sensors are very important for us to know. I have to sense at a particular place toxic material is there or not. Can it sense? And if it's having a good sensitivity, I have my polymer which is irradiated, I keep it there, I can find out a material at ppb level, parts per billion level. In this material, in this particular atmosphere, this many number of this many parts per billion of a toxic material is present, and how do I rectify that? Okay, so that's the best application that we found out is in this with this material particularly, and the supercapacitor capacity, the capacity of the microfarads, picofarads तक ही बात होती थी, लेकिन now we have gone up to the level of the superfarads. Okay, so these are some of the materials that we have already done the studies. मैंने जो आपको यहाँ पे जो studies what I have shown here are only few of them, but it's not limited to that. So अभी मैं वो सब तो दिखा नहीं रहा हूँ, this one slide, इसके बाद वाली. Yeah, good. So you have the ions which are silver and nickel and carbon. Silver beam of 100 MeV, nickel 100 MeV, carbon of 40 MeV, 80 MeV. Now again I am restricted to energy. जितनी low energy होगी, low mass material होगा, I have to use its energy lesser and lesser. Yeah, I'll be finishing. Yeah. So you can see that the carbon beam is I'm restricted up to 40 MeV only. When these materials are used, when these ions are used, जो आप वो SE देख रहे हैं, that SE is basically D by dx, the number of the change in energy with time. So when this material passes through, and when this material passes through, it loses its energy. Well, the loss in energy is called the d by dx, the change in energy per unit time, per unit distance. कितनी एनर्जी गई अंदर गई और किस एनर्जी में कितनी एनर्जी बदल गई. I have shot this with 100 MeV gold beam or silver beam, but then at this particular thickness उसकी एनर्जी कितनी कम हुई. So that is d by dx, and d by dx can be because of its interaction. See, you have, as I said initially, I have a positive particles going and positive particles coming out, but the material with which it is interacting is the nucleus only, and that is positively charged only. So when it interacts, it loses its energy because of the electrons, है ना. The electrons are only providing जो basic interaction जो है वो electrons को जो है energy transfer करना है. That energy is being transferred to the electrons. So the energy loss is because of the electrons there. Okay, so it's called the d by dx electronic energy loss. लेकिन एक level पे क्या होगा, at some point of time the energy loss is also because of the nucleus which is positively charged. So the d by dx proton, the and nucleus is also there. So but at any place the electronic energy loss is higher, you see, and proton energy loss, the nuclear energy loss is always lesser. You can see that. Okay, this is the number of ions that are going and hitting there. So with that change, what's basically happened? अब ये सब study करने के बाद, now when I come to the finally can see is how the FTIR is changing with fluence, how the change is taking place. And in this, what we found is that this is a different fluences, and by what we found is at a particular fluence, we get the best kind of material which can be used for our device studies. Okay, next slide. At particular fluence, what's happening, and this fluence gives me how much of the X-ray, how the energy is changing, how the X-ray is showing. So you can see is that XRD becomes higher and higher. I mean, its peak increase hoti. That peak increasing means it is more becoming towards crystalline like, although it is material which is organic in nature, lekin it is more turning towards the crystalline side. Okay, so its crystallinity is increasing basically with fluence. One can see that. Okay, with fluence the crystallinity is increasing. Next slide. Some such studies where we can see that this is the material which gives me a good crystalline material. Okay, so the morphology has changed from here to highest fluence. You get a good morphology. That means it is more, and morphology is at the level of nanometers. So what you cannot see the material is, agar aap ऐसे देखेंगे तो the material is the same material, but then at the nano level the things have changed. It has become more morphological in nature. Next slide. These are some of the slides that I just wanted to show, and there are many things to continue in this. Next. Yeah. So I conclude by saying that with this fluences, with change in the material, the kind of material that I use, with change in the and beam that I use, I can make many such material modification given a device. So that's what we have been working on, and I'm sorry for the indiscrepancies because there are many things that I keep losing, and there are many things that I keep getting back also. So I'm trying to sort of, combine those two things together. So thank you so much.
Thank you. Thank you, sir, for a wonderful talk. Can we have like one or two questions? Do you have any? Yeah.
I'm Mubashir Azam, sir. I have some questions. As you said, sir, you are irradiating fluence per centimeter, something like this, for 10 seconds, 20 seconds, 30 seconds. And when I was working as a radiation safety officer at BB Cancer Hospital, the students from Osmania University used to come to irradiate the seats on gamma rays. Okay. Photons. We were using the gamma cobalt 60. That time their plant was not working. They used to come to me. So we used to irradiate for 100 rats, 200 centigrade, 300 centigrade for this one. Yeah. And as you said here, fluence rate. So I think that it can be changed to how much dose absorbed by your material. That will also change. Yeah. And next thing, sir, what I want to say, our students of this university, if they want some irradiation for seed, because when I was working in Sushruta Cancer Hospital, somebody came with white mice. They said, sir, you irradiate whole body white mice, so that in case of atomic reactor, in case of atomic bomb, if how many days, so I irradiated the white mice that time. So this field is very much open, sir, not only to polymer, seed, and white mice. So one can do many research. If they want irradiation, I can help for irradiation for gamma photon.
The beams at the International Extension Center is open to any such research studies basically, and there we not only they not only confined to only one particular field. The biological samples have also been irradiated, and that have also been studied at both at low energy levels like 2 MeV, 100 MeV, in fact keV, few 40 keV, kilo electron volts, at those energies also, and at a higher energy levels also, and medicines, the medicinal use of irradiated materials, that also is a separate study, and I'm telling you, it's a whole branch of physics that opens up there. So
and one more thing, sir, you have not shown that how much resistance change after irradiation, means in ohms, like
yeah, resistivity
how much it is reduced.
Then the resistivity changes quite a bit. In some of my actually samples, the resistivity changes from semiconducting to superconducting levels also. So some of the materials they become transfer to superconducting levels, but then we are restricted with temperature also. So we have to keep in mind that at that suddenly the temperature increases. If temperature increases, then it can affect some other things also. So we have to keep. I mean, we have to have a balance between all these things. So we work on that.
Okay, sir. Nice, sir.
Thank you.
Any other questions? If not, I invite Dr. Mehkum to propose a vote of thanks.
Good afternoon to everyone. Ladies and gentlemen, esteemed guests, respected teachers, and dear students. On behalf of the organizing committee, I stand before you with a heart full of gratitude and a sense of accomplishment as we conclude this celebration of National Science Day 2024. We have immersed ourselves in the spirit of scientific inquiry and innovation, or any remarkable achievement, and that we shape the world of science. First and foremost, I extend my heartfelt thanks to chief guest Professor Azhar Majid Siddiqui, whose insightful words have enlightened us and inspired a deeper appreciation for the significance of science in our lives. Your presence has added immense value to our celebration, and we are truly grateful for your time and wisdom. We are also thankful guest of honor, Professor P.K. Suresh, for his presence. We will have the opportunity to hear more in the next session. We are grateful to our registrar, Professor Ishtiaq Ahmed, for presiding over today's function. Your presence is always motivation and inspiring to us. A special thanks to our Dean, Professor Salman Ahmed Khan, and Director of this program, Professor Alim Basha. Your guidance is the cornerstone of our scientific journey, and we often acknowledge the pivotal role you play in shaping the future of our budding scientists. I would also like to express our gratitude to the conveners, co-conveners, organizing committee, engineering section, teaching, non-teaching staff, and the volunteers who work tirelessly behind the scene to ensure the smooth execution of this event. Your dedication and hard work have contributed to making this National Science Day celebration a resounding success. Some words to our students, the future torchbearers of scientific progress. Your enthusiasm and participation have added vibrancy to this occasion. May you continue to explore the wonders of science and contribute to the advancement of knowledge for the betterment of society. Thank you once again to everyone who has been a part of this celebration. May the flame of scientific curiosity burn bright in our hearts, lighting the way for brighter and more enlightened tomorrow. Thank you. Kindly. kindly gather outside the podium for the tea break. Thank you.
We will have a very short tea break of 5 minutes because we are running late, and I request students to come back for this next lecture. It is basically on gravity. You will definitely enjoy and learn a lot about gravity. So please do join